Hello everyone, welcome back to HVAC official channel. Today, I am bringing you one of the most complete and important videos I have ever made on this channel. HVAC fundamentals, from beginner to pro, everything in one video. Guys, whether you are just starting your HVAC journey or you have been working in the field for a while and want to solidify your foundation knowledge, this video is made exactly for you. Before you can fix a system, you need to understand why it works. The fundamentals of HVAC are built on basic principles of physics and chemistry. At its heart, HVAC is the science of moving heat. So, let us build that foundation together correctly and completely today. Let's go! What does HVAC mean? HVAC represents the complete climate control infrastructure in your home. The acronym breaks down into three functions. Heating warms your space during cold months. Ventilation exchanges indoor air with fresh outdoor air while removing pollutants and moisture. And air conditioning cools and dehumidifies during warmer periods. Guys, so HVAC is not just about your AC or your heater as separate things. It is the complete system that handles temperature, humidity, ventilation, and air quality together as one integrated package. Your HVAC setup is not a single appliance. It is a network of interconnected units that regulate indoor temperature and air quality throughout your living space. Understanding this from the very beginning is critical, because every decision you make as a technician, whether it is about sizing, installation, maintenance, or troubleshooting, connects back to this bigger picture of what the system is trying to achieve. The science behind HVAC. Thermodynamics. Guys, before we talk about components and systems, I want to make sure you truly understand the science that makes HVAC work. Basic thermodynamics teaches us two key rules. First, energy cannot be created or destroyed, only moved around. Second, heat naturally flows from a warmer area to a cooler one. An air conditioner does not create cold. It simply moves heat from inside your house to the outside, which requires work from the compressor to go against its natural flow. This is genuinely the most important concept in all of HVAC, guys. Your AC is not a cold-generating machine. It is a heat-moving machine. Everything inside the system, every component, every process, every measurement, is ultimately about moving heat from one place to another. When you internalize this simple truth, suddenly every other concept in HVAC starts making more sense. Why the outdoor unit blows hot air, why the indoor unit feels cold, why the compressor uses electricity, and why refrigerant is the essential working fluid that makes all of this possible. The three methods of heat transfer. Guys, heat moves between places through three different methods, and understanding all three is essential for any HVAC professional. The first method is conduction. This is when heat transfers directly through a solid material by contact. Think of a copper refrigerant pipe getting hot when refrigerant inside is warm. The heat conducts directly through the copper wall. Copper is used for refrigerant piping specifically because it is an excellent heat conductor. The second method is convection. This is when heat transfers through a moving fluid, either liquid or gas. When your air handler's blower fan circulates warm room air over the cold evaporator coil, that is convection heat transfer at work. The air carries the heat energy from your room to the coil surface. The third method is radiation. This is when heat transfers through electromagnetic waves without needing any physical contact or medium at all. The heat you feel from the sun on a clear day or from a heat lamp in a bathroom is radiant heat transfer. In HVAC, understanding radiation matters because solar heat gain through windows and walls significantly affects the cooling load your system must handle. The vapor compression refrigeration cycle. Guys, this is the engine that powers almost every air conditioner, refrigerator, heat pump, and chiller in the world. The vapor compression refrigeration cycle has 4 stages, and every HVAC technician must know these perfectly. The first stage is compression. The compressor takes low-pressure refrigerant vapor from the evaporator and compresses it, raising both its pressure and its temperature significantly. The refrigerant leaves the compressor as high-pressure, high-temperature superheated vapor. The compressor is the only component in the cycle that requires electrical energy input, and it is the heart of the entire system. The second stage is condensation. This hot superheated vapor travels to the condenser coil. In air-cooled systems, a fan blows outdoor air across this coil. Because the refrigerant is hotter than the outside air, heat transfers from the refrigerant into the outdoor air. As the refrigerant loses heat, it cools down and condenses from hot gas into a warm, high-pressure liquid. This is exactly why the outdoor unit always blows very hot air. It is expelling your room's heat to the outside world. The third stage is expansion. The warm, high-pressure liquid refrigerant now enters the expansion device. This could be a capillary tube in simpler systems, or a thermostatic expansion valve in more advanced ones. As the refrigerant passes through this restriction, its pressure drops suddenly and dramatically. Because pressure and temperature are directly linked in refrigerant behavior, this pressure drop causes an equally dramatic temperature drop.
The refrigerant exits the expansion device as a very cold, low-pressure mixture of liquid and vapor, ready to absorb heat. The fourth stage is evaporation. This cold, low-pressure refrigerant mixture enters the evaporator coil inside the indoor unit. The blower fan pulls warm room air across this cold coil. Heat transfers from the warm room air into the cold refrigerant. The refrigerant absorbs that heat and evaporates, changing from liquid to vapor. The room air loses its heat and becomes cooler. The cooled air is then blown back into the room. The refrigerant, now carrying all that absorbed room heat, returns to the compressor as low-pressure vapor, and the entire cycle repeats continuously. Key HVAC measurements every technician must know. Guys, HVAC work involves several specific measurements that you will use constantly in the field. Understanding what each one means and why it matters is fundamental to doing your job correctly. We measure heat energy in British thermal units or BTUs. 1 BTU is the amount of energy needed to raise 1 pound of water by 1 degree Fahrenheit. An air conditioner's capacity is rated in BTUs per hour. A standard 1-ton AC system has a cooling capacity of 12,000 BTUs per hour. This is the fundamental unit you use when sizing AC systems for rooms and buildings. Tons of refrigeration is directly related to BTUs. 1 ton of refrigeration equals 12,000 BTUs per hour of cooling capacity. So a 1.5-ton split AC has 18,000 BTUs per hour of capacity, and a 2-ton unit has 24,000 BTUs per hour. CFM, cubic feet per minute, measures the volume of air your system moves every minute. The industry rule of thumb is approximately 400 CFM per ton of cooling capacity. Correct airflow is just as important as correct refrigerant charge. A system with perfect refrigerant charge but wrong CFM will still perform poorly. EER, energy efficiency ratio, tells you how efficiently your system cools for every watt of electricity it consumes. A higher EER means a more efficient system and a lower electricity bill for the same amount of cooling. COP, coefficient of performance, is a broader efficiency measurement used especially for heat pumps and chillers. COP equals the useful cooling or heating output divided by the electrical energy input. A COP of 4 means the system produces 4 units of useful cooling for every 1 unit of electricity consumed. Superheat and subcooling are the refrigerant measurements that tell you whether the system is correctly charged and whether all components are functioning properly. Superheat is how much hotter the refrigerant vapor is above its boiling point at the evaporator outlet. Ideal range is 10 to 20 degrees Fahrenheit for most systems. Subcooling is how much cooler the liquid refrigerant is below its condensing point at the condenser outlet. Ideal range is 10 to 15 degrees Fahrenheit. These two measurements together give a professional technician a complete picture of system health on every single service call. Main components of an HVAC system. The thermostat is the brain and control center of the entire HVAC system. It continuously senses the indoor temperature and compares it to the set point you have chosen. When the actual temperature differs from the set point by more than a small margin, the thermostat sends an electrical signal to start the heating or cooling equipment. When the desired temperature is reached, it signals the equipment to stop. Modern smart thermostats connect to Wi-Fi and can be controlled remotely from a smartphone, and many learn your daily patterns over time to automatically optimize comfort and energy use. The compressor is the heart of the refrigeration cycle and the single most expensive component in any AC system. It pumps and pressurizes the refrigerant, enabling the entire vapor compression cycle to function. Compressors come in several types: reciprocating, rotary, scroll, and centrifugal.
each suited to different system sizes and applications. Modern inverter compressors run at variable speeds controlled by an electronic drive, adjusting output in real time to match the actual cooling demand, which is what makes inverter systems so much more energy efficient than older fixed-speed compressors. The condenser coil is located in the outdoor unit. It receives hot, high-pressure refrigerant vapor from the compressor and releases its heat to the outside air with the help of a condenser fan. As the refrigerant releases heat, it condenses from hot vapor into warm liquid. Keeping the condenser coil clean is one of the most important maintenance tasks in any HVAC system. A dirty condenser directly increases electricity consumption and puts unnecessary stress on the compressor. The evaporator coil is located in the indoor unit. It receives cold, low-pressure refrigerant from the expansion device and absorbs heat from the indoor air that passes over it. This heat absorption is what actually cools your room air. The evaporator coil also dehumidifies the air as it cools. Moisture from the air condenses on the cold coil surface and drips into the drain pan below, which is why your AC removes humidity from your home. The expansion device, either a capillary tube or a thermostatic expansion valve, controls the flow of refrigerant into the evaporator coil and creates the pressure drop that converts warm, high-pressure liquid refrigerant into cold, low-pressure refrigerant ready to absorb heat. The air handler and blower fans circulate air through the ductwork system, delivering conditioned air to every room and returning used room air back to the system for reconditioning. The air filter protects the evaporator coil and blower from dust and debris. A clean filter allows proper airflow and ensures the system can perform at its designed efficiency. A clogged filter is the single most common cause of reduced cooling performance, higher electricity bills, and frozen evaporator coils. Heating in HVAC. Guys, HVAC is not only about cooling. The H in HVAC stands for heating. And understanding the heating side is equally important for a complete professional. Heating provides warmth during colder months using systems like furnaces, boilers, or heat pumps. Furnaces typically use gas or electricity to generate heat and distribute it through ducts. A gas furnace burns natural gas or propane inside a heat exchanger. The combustion gases pass through the heat exchanger, transferring their heat to the indoor air without mixing with it. For safety, the blower then pushes this warmed air through the ductwork. An electric furnace works identically, but uses electric resistance heating elements instead of combustion. A heat pump provides heating by reversing the refrigeration cycle. Instead of pumping heat from indoors to outdoors, it pumps heat from the outdoor air to indoors. Even on a cold day, there is still heat energy available in the outdoor air, and a heat pump extracts that energy and moves it inside. This is significantly more energy efficient than generating heat directly through combustion or electric resistance. Ventilation, the most overlooked V in HVAC. Ventilation exchanges indoor air with fresh outdoor air while removing pollutants and moisture. Ventilation manages carbon dioxide levels. Guys, ventilation is genuinely the most overlooked and underappreciated part of HVAC, but it is absolutely critical for health and safety. People in modern buildings spend the majority of their time indoors. Without proper ventilation, carbon dioxide from breathing builds up, humidity rises, odors accumulate, and indoor pollutants from furniture, carpets, cleaning products, and cooking reach unhealthy levels. Mechanical ventilation systems, including air handling units, energy recovery ventilators, and heat recovery ventilators, bring controlled amounts of fresh outdoor air into the building, filter it, condition it to the correct temperature, and distribute it to occupied spaces. In commercial buildings, local building codes specify minimum ventilation rates, measured in CFM per person or CFM per square foot, that must be maintained at all times for occupant health and safety compliance. Refrigerants. What every HVAC technician must know in 2026. Guys, refrigerant knowledge is non-negotiable for any HVAC professional. Refrigerant is the chemical working fluid that actually carries heat through the refrigeration cycle, absorbing it at the evaporator and releasing it at the condenser. Without refrigerant, there is no heat transfer and no cooling. R22 was the standard residential refrigerant for decades, but has been phased out worldwide due to its ozone-depleting properties. R410A replaced R22 as the dominant refrigerant in most split AC systems. But now, in 2026, R410A itself is being phased out and replaced with newer, more environmentally friendly refrigerants. The industry is now transitioning to R32 and R454B as the primary replacements for R410A. R32 has a global warming potential of 675, significantly lower than R410A's 2088. R454B has an even lower global warming potential. These newer refrigerants are considered A2L class, meaning they are mildly flammable, which requires technicians to follow updated safety and handling procedures that are different from what was required for R22 and R410A. Refrigerant does not get consumed like fuel. It circulates in a sealed, closed-loop system indefinitely. If refrigerant levels are ever low, it always means there is a leak somewhere. Leaks must be found and repaired before recharging. Simply adding refrigerant without repairing the leak is not a professional repair and wastes money and refrigerant. Handling refrigerant also requires proper certification. Releasing refrigerant into the atmosphere is illegal in most countries and harmful to the environment. HVAC tools every technician must know. Guys, no HVAC technician can do their job effectively without the right tools. Let me walk you through the essential tools you will use constantly in the field. A manifold gauge set is the most fundamental diagnostic tool in refrigeration work. It connects to the service ports of the AC system and shows you the suction pressure on the low side blue gauge and the discharge pressure on the high side red gauge. These two pressure readings, combined with temperature measurements, allow you to calculate superheat and subcooling, check refrigerant charge, diagnose component problems, and verify system performance. A digital multimeter is the essential electrical diagnostic tool. You use it to measure voltage, current, resistance, and continuity across electrical components, checking for shorts, open circuits, correct voltage supply, and component health. A clamp meter measures AC current without breaking the circuit. You simply clamp it around a wire to read the current draw of the compressor, fan motor, or any other component. A vacuum pump is used during installation and after any refrigerant work to evacuate the system, removing all moisture and non-condensable gases from the refrigerant lines before charging. Proper evacuation to at least 500 microns is absolutely essential. Moisture left in the system causes acid formation, compressor damage, and premature system failure. A refrigerant scale is used to measure the exact weight of refrigerant being charged into a system. Charging by weight is the most accurate method and is required for sealed factory systems and systems with fixed orifice metering devices. A leak detector, either electronic or UV dye-based, is used to locate refrigerant leaks anywhere in the system. Finding and repairing the leak is always the first step before any recharge. HVAC safety, non-negotiable rules. Guys, HVAC work involves electricity, refrigerants, rotating machinery, high pressures, and sometimes working at heights. Safety is not optional. It is the foundation of professional HVAC work. Always switch off main power and verify it is off before working on any electrical component. Never work on a live circuit. Always wear appropriate personal protective equipment. Safety glasses, insulated gloves, and safety-toed boots are the minimum for any HVAC job. When working with refrigerants, always use proper recovery equipment. Never vent refrigerant directly to the atmosphere. It is both illegal and environmentally harmful. Always discharge capacitors safely before touching them. They store dangerous electrical charge even after the power is disconnected. When using nitrogen for pressure testing, always use a regulator. Never connect a nitrogen cylinder directly to a system without a pressure regulator in line. Always use nitrogen for pressure testing. Never oxygen or compressed air. Oxygen mixed with compressor oil can cause a dangerous explosion. And always follow the manufacturer's specifications and local codes for every installation and repair. Guessing or cutting corners is how expensive callbacks and serious safety incidents happen. Your HVAC career path. Understanding the fundamentals of HVAC. Identifying basic components. Using basic HVAC tools. Differentiating HVAC system types. Performing basic maintenance. These are the building blocks of a rewarding HVAC career. Guys, the HVAC industry is one of the most stable, in-demand, and well-paying skilled trades in the world in 2026. The career path is clear and achievable. You start as a helper or apprentice, learning hands-on from experienced technicians on real jobs. After 1 to 2 years, you become a qualified technician capable of servicing and repairing systems independently. With experience, you progress to senior technician, then supervisor or foreman, then project manager or HVAC engineer, or you start your own business. The knowledge you are building right now, by watching this video and learning these fundamentals, is the same foundation that every successful HVAC professional in the world started with. Guys, we covered a tremendous amount of correct and important information today. HVAC stands for heating, ventilation, and air conditioning. It is the complete system that controls indoor comfort and air quality. HVAC is fundamentally the science of moving heat using thermodynamics. The vapor compression cycle, compression, condensation, expansion, evaporation, is the engine behind every AC system. Key measurements: BTU, tons, CFM, EER, COP, superheat, and subcooling are the language of professional HVAC work. The main components: thermostat, compressor, condenser, evaporator, expansion device, air handler, filter, all work as one team. Refrigerants are transitioning in 2026 from R410A toward R32 and R454B. The right tools and strict safety practices are non-negotiable on every job, and the HVAC career path offers real growth, real income, and real job security for anyone willing to learn and work hard. If this video helped you, please like and share it. Share it with every person who is just starting their HVAC journey and needs this foundation.